Welcome back to Summarize Science. Today we are looking at a breakthrough in medical imaging that helps doctors navigate the lungs during a procedure called a bronchoscopy. A major challenge in lung procedures is that the airway moves between 5 to 20 millimeters every time a patient breathes. This creates a mismatch between the pre-surgery CT scan and the patient's actual body, leading to errors in finding tumors or lesions. Right now, doctors often ask patients to hold their breath to keep things still, but this is difficult to repeat and can be very uncomfortable. Existing navigation methods usually just assume the airway is static, which can lead to missed targets. Instead of fighting the movement, researchers found a way to embrace it by using two different CT scans. They take one scan for a full inhale and one for a full exhale to capture the entire range of motion. By comparing these two scans, they created a mathematical model of how that specific patient's airway deforms. They used a cutting-edge technique called Gaussian Splatting to create a detailed 3D reconstruction that moves in real time. The system uses small 3D primitives called Gaussians that are anchored to the lung surface. As the virtual lung breathes, these particles move along with the tissue, maintaining a perfect 3D view. A clever part of this system is that it can estimate which part of the breathing cycle the patient is in just by looking at the camera feed. It uses a special mathematical function to ensure the AI doesn't get stuck at the full breath or empty breath points. Because there wasn't a good way to test this on real people yet, the team built a simulation framework called Respire. This tool generates realistic lung videos that include depth and motion data so the AI can learn what a moving lung looks like. The simulator even mimics how light reflects off wet tissue and how colors vary inside the human body. This makes the training data much more useful for real-world medical applications. In their experiments, this new method was over 20 times faster to train than older AI models. It consistently outperformed other systems in terms of how clear the images were and how accurately it mapped the depth of the lungs. Most importantly, it achieved a target accuracy of about 1.22 millimeters. This is well within the safety limits required for a doctor to successfully perform a biopsy. In summary, researchers have shown that lung movement can be predicted using low-dimensional models based on existing clinical scans. By reducing the motion to a single breathing phase parameter, they have made surgery much more accurate. In the future, this could eliminate the need for patients to hold their breath during surgery entirely. It could lead to self-supervised navigation systems that guide doctors through the branching paths of the lungs with incredible precision. Thanks for watching Summarize Science.